I have a window, an exhaust fan, and a central air duct in my bathroom. When I run the supply duct, there is no condensation on my mirror after I shower, and very little on the ceiling. Neither the fan nor the window do a very good job of dehumidification. At the previous house, I had a return duct that did not extract humidity as well. A central air supply duct is the best way to keep a bathroom dehumidified, and architects and HVAC installers should plan things around this. But I acknowledge that very few building systems are ever built optimally due to their age, financial constraints, or inexperienced people involved in the process. I live in Minnesota, and an abundance of basements makes the installation of large plenums and straight rigid ducts very easy. This allows for generous airflow even with very modestly sized blower fans that draw very modest amounts of power. Southern climates often lack this luxury, and I don't understand how attic ducts could ever be installed properly. In the multifamily buildings that I work on, I see a lot of magic packs that either have ducts hidden in the chase on the upper corners of walls, or just try to present ducts as industrial chic. The chases introduce a bunch of extra turns to the duct, reducing airflow, and the lack of a large plenum slightly restricts the air even when ducts are exposed. Magic pack ducting practices could allow southern production builders to achieve almost as much airflow and energy efficiency as northern builders while only sacrificing a couple of square feet. Custom southern builders should opt for encapsulated attics with a custom truss plan that allows for rigid attic ducts that only turn vertically, which would allow for southern HVAC systems to deliver a lot of airflow without dumping electricity. I worked at a high-rise where all the units used P-tax or hotel heaters to heat and cool, and none of the bathrooms were on an exterior wall. They all had remote or inline exhaust fans running from the bathrooms to the exterior of the building. The code does require either an exhaust fan or a window, and moving all the plumbing to an interior wall does help with frost protection and lowering construction costs. But I think that all the money put into ducting could have been better spent on a central air system. The building code should be expanded to allow for a central air duct instead of a vent or window, even though that raises questions about whether makeup air and ducted dehumidifiers should also be required. They should also be required. Many magic packs are already installed with primitive makeup air systems, and many new cooling systems already have a dehumidify setting. The current minimum for bathroom fan vents is 50 CFM intermittent or 20 CFM continuous, which is negligible, but I understand why. If you're going to install a tiny fan in a wall cavity, it's going to make a racket if you get it over 5 CFM, because small fans make a ton of noise. A large fan can move a ton of CFM while not being audible or damaging themselves with vibration. I've seen multiple fires started by bath fans shaking themselves apart. I've had a bunch of tenants tear out their own bath fans because of noise, and I've spent hundreds of hours cleaning bath fans because the moist air isn't filtered as it enters. A lot of engineering has gone into alleviating some of these problems when all of these problems could be solved with a central air supply duct pumping 300 to 600 CFM in from a remote location. Furnace blowers are typically rated at 1 to 2,000 CFM, and people can rarely hear them. They are a solution to a bunch of problems. A very minor update to the building code could solve millions of wasted man-hours every year and effectively ban a lot of substandard architecture.